If you ever have the needs to shoot some clips from the top of your desk or all around it to show how you build things, well, this video is for you. So stick around because today we're going to show you how to 3D print and customize and build this amazing slider for your camera with mechanical arms and a custom quick release that I designed especially for this project. This is going to be a fairly long video, so without further ado, let's do it. Hey guys, welcome back to the channel. My name is Alessio and this is Spectrum Filaments. A couple of weeks ago, I was working on other projects, and while I was filming some clips, I was wondering, why do I have to move my tripod or use another camera to shoot some other clips, for example, from the top or the side or other angles? I need something else. So I did the research on MakerWorld and other websites to find something that I can use. And I landed on two specifically, the one that I actually built and another one that I tested. In the second, I'll show you all the process I've been through to get to this point. For this particular project, I used this amazing filament called the Filament PETG Carbon. And for only 30 days, you can find the 20% discount code SPEC-MECH down in the description, and it will come in three colors: gray, purple, and red. As well as this discounted filament, you will find the links for all the other filaments that I used for this project. But only this filament will have a discount of 20% off. And now I'm going to show you how I built it. Before we dive in to assemble this contraption, setup, mechanical arm, camera holder thingy, we're gonna take a quick look on what's on the table, what do you need, and which material I use for this build. So for this build, the main material is the Filament PETG Carbon. And I have to say, this thing is strong and almost a little bit flexible, but I have to say it's bloody amazing. It's super sturdy. I already tested it, of course, but yeah, you can tell it's really strong. So I used the Filament PETG Carbon for the rails because the rails are going to go around the table and the corner as well, and they have to hold the whole setup. So I thought, why not using this filament to see how strong it actually is. Then we use the same material for the mechanical arms, and I have to say, these are bloody strong. You can tell I'm trying to flex them, to break them. It's really hard, and is a little bit flexible too, like I said previously. And for the Filament PETG Carbon, I used a custom profile that you can download in the description down below, or you can use these settings right on the screen. Just bear in mind that this material is very abrasive and tends to clog quite easily. And another thing I like to mention is that I had to file down all these parts right here because I forgot to put supports in them, in literally all of them. But yeah, that's part of the job, and it was fun anyway. This is where the M3 screws will go with their own clamps. Obviously, because this is abrasive, it's a must to use a hardened steel nozzle, so do that. And for the Filament PETG Carbon, we have the rails, like I said, the angle one, the straight one, and the end and the beginning of the rails. All the files for this project are going to be in the description down below, but there are so many different variations. This is my own remix. These are the original files, and this is a remix. This is a remix as well, and a couple of other remixes, completely fully customized, and we're gonna get to this one later. For the second main material, I went for the Spectrum PA12 CF15, which is amazing, carbon black, and it turned out great. This print took a very long time. Pretty much all the files except the quick release plate and these little caps that are soft, and we're gonna go to this one later, have been printed with two Bambu Lab P1S with hardened steel nozzle. And it took around 11 hours to print all these clamps. There was, I think, 6 on each plate, and you can see the time lapse, of course, in the screen. This material is amazing. It's really flexible and it's really strong. Like I said, I already tested it and it really holds up. This one, because it's a modification, it's a remix. The original clamp is actually really short. It's not this long and it's actually shorter because the desk that I have is a heavy duty desk. It's not a normal desk. So it's not this thin, and you know, I had to modify it. So this one could be a little bit of a flimsy, it's a little bit weak, but I have to say, after testing it, it really does the job and it holds in place perfectly, and we're gonna see the final result in a bit. And for the Filament PETG Carbon, we're gonna give a 20% discount, and the link is in the description down below. Also, the Spectrum PA12 CF15 is in the description down below if you wanted to purchase it. The next abrasive filament was the ASA 275 that I used for the screws and the key to, of course, open and close the screws accordingly. I gotta say, this material is very doughy. It's really dense, that's what I mean, but it's really strong. Unfortunately, I had a little issues here and there with some of the screws. As you can see, the first layer actually came off and stayed on the build plate, which is really good adhesion, but on the other hand, you know, it just came off and it kind of got stuck to the build plate, which was really hard to remove. So be careful with this because, like I said, it's really dense. The screws have to be strong, so this is perfect. And again, Spectrum ASA 275 is in the description down below if you want to try it out for yourself. I also printed some extra screws with the PA12CF15 just in case to have some extra and have a different look. For example, on the mechanical arm, I wanted to go with the white ones, but I figured that maybe it will look better with black. I don't know, I'm not sure yet which one I'm gonna use for the final build, but we'll see. And that's that for the abrasive material. And next we have the quick release plate. This is my design, the top part, it's my design, and I'm gonna show you all the iteration that I went through to get to this point where I can actually put the camera in, lock it in place with 2 magnets, and it will just hold perfectly. We have a little screw as well that goes in there and it will hold perfectly right there. There you go. It's not a perfect setup because it kind of flexes too much, but it does the job, so we'll go with this one. And these are the first 2 iterations of the quick release plate that I then modified, and as you can see, is not perfect. And also I kind of went for this little M3 to hold the camera in place, but it wasn't really working. Even like that, it was pretty flimsy. Even if you screw it in, hold it like that, and screw the arm really tight, and the bottom as well, and you can swivel it like that, place it as the way you want, but as you can see, it's really flimsy. Imagine the camera on top of it, it was wobbling really badly. The difference between these 2 was just the gap between the base and the angle part, and was actually fitting the quick release plate of the camera better. I managed to remove maybe 0.5 millimeters, 1 millimeter all around, so that means 0.5 here and 0.5 there. Then we have iteration number 3, which turned out not great to hold it perfectly, so it kind of slides in right there. Let's pretend that this is the camera, you slide it in, and then you just put this one right there, and it should hold it. And it works. This one is a little flimsy, and the gap from the base to the actual system, it's really thin, so it could break easily. And I want to mention that all the prototypes were printed with basic PLA, which is great. And in Bamboo Studio Slicer, I used 1 wall around and 5% infill just to not waste material, and for the prototypes it's just fine. And I went for number 4, and number 4 is a little different. There is like this new system that I thought is going to be stronger with the cylinder locking system that should have held it better, but unfortunately it didn't. As you can see, it comes out pretty easily. Because the device itself, it's really thin, especially right here. There's only like 5 millimeters, I think. There's no space for a bigger indentation to hold it in. Iteration number 5, I went a little bit more inside. The extrusion is actually a little bit more inside like that, and it was holding it better. It kind of goes well, and lock it in place, and it works. Still a little wobbly because the measurements were not finished yet, but I figured I need something else. I don't know, it looks a little flimsy. Maybe it will come off. So I had to figure out another way to build this. Iteration number 5 comes in. I thought it's gonna be the last one using the same system as before, but adding a little handle to the locking system so I can remove it easily. And unfortunately, it comes out again, because it depends also on the material you are using. And again, I think this system wasn't that great. Also, it's too thin, it could break easily. There you go, broken. So, number 6, out of the way. And that's where I came up with a new idea, iteration number 7. I rebuilt the whole thing from scratch with the new quick release profile, which holds a little better. It's literally perfect. Also, this is because there is only 1 wall and 5% infill. It just came off right away, but we don't need it. And this was just a fit test, and it's perfect. So I decided to go with this. Iteration number 8, I made the gap a little larger to give it more room, and it works perfect. And basically, this is the iteration number 9. And this is where it gets creative, because I added magnets with the same profile on the locking system, so it will lock already, Plus you have the magnets for extra strength, and it's perfect. Goes right in, lock it in. Now this one doesn't have the magnets, but you saw it already. And after that, iteration number 10, and this was printed with the filament PETG that I showed you before, and the fit is perfect. And this is the final version, iteration number 11. Lock it in, the magnet's already working, boom. Let's put the quick release plate back in there, magnet, perfect. And it stays right there. Before we got to the end result, I went through a couple of iterations of different models. This one was one of the candidates. The link is in the description down below, and I had to modify the clamp accordingly to my desk because, like I said, it's really thick and it's heavy duty, and there is this little angle. And this is the original clamp that I modified from this to this. As you can see, is a little bit taller and longer in order to fit my desk, and it worked perfectly. The original files are in the description down below along with my remixes. And as you can see, the arms are way shorter than the final model, which means they're going to hold more weight, they're going to be stronger, especially with this material. But this file is not bad if you want to hold a phone. In fact, this was designed as a phone holder, a tablet holder. You clamp it on your desk like that. Even for the rails and the clamps, the final versions, I went for basic PLA and one wall, 5% in fill, just to try them out. And even this one is just printed halfway through, but even the screw works, so I could see if it holds up. It was fine, it was flush to the surface. And here were all the pieces that I used, and this was the device itself. Like I mentioned before, I added a little fillet on the base of this one, of the finger screw, right there, just to make it slide better on the slider themselves, because this one gets stuck all the time. The arms are perfect. Also, this one were printed with basic PLA with one wall, 5% in fill, just to try them out. And then we have the finger screw and the finger nut. It works really well. Also, I modified this version because this was too sharp for my taste, because this part goes inside the rail like this, and it have to slide. And with the prototype that I'm gonna show you in a bit, you can see that it's not optimal to get, it's gonna get stuck all the time, even like that. So with a little fillet, it's going pretty well. And for this filament, I used a really nice PETG, the filament PETG black. And I have to say, this material went smooth like butter. I printed a couple of prototypes and tests with this material, and I have to say it went smooth, super smooth. It looks shiny, and I went for this color because pretty much everything is black, and the top I want it to be black like the camera, and that's what I went for. And if you want to try this filament for yourself, this is the filament PETG Midnight Black. Check in the description down below. Last but not least, we have this little screw caps that are going to be placed on the screw itself like this, and they were printed in TPU 98A. This is the Spectrum S-Flex 98A. These were printed on a Bambu Lab A1, and it went smoothly with no hiccups, maybe just one hiccup. I don't know, for some reason, just one of the screw came out this way. I have no idea why. Only 1 out of 12, and this is a mystery, but you know, this is 3D printing. But this is still functional, as you can see right here, and this one goes under the table with a clamp like that, so it will hold more tightly and it will not ruin your desk. How many parts and pieces do we need for this build? 3 straight rails, 1 beginning, 1 end, and a curved angle one as well, of course, for the corner of the desk. Then we need 3 arms, 2 on the base and 1 on the top. There is a shorter version as well if you want extra movement on your camera, on your angles, just in case. Just bear in mind there's going to be more weight onto the mechanical arms, and it will tend to flex a little bit more. We will see that later. So it's 3 rails multiplied by 2 is going to be 6 clamps just for the 3 straight rails. And we have them right there, 1, 2, 3, 4, 5, and 6. And then other 6, because we have the 2 endings, which is other 4 clamps. And then we have the curved angle, which is going to be other 2, 1 and 2. So it's going to be other 6, 1, 2, 3, 4, 5, and 6. Obviously, we have the soft screw for the clamps, and then we have all the screws for the clamps themselves. Then we have the quick release plate system right here. Its own screw, of course, the nut and the finger, and there we go. And with no further ado, it's time to build it. Now for the build, what do we need? We need all the pieces we printed, and then we need only just some hardware, which is going to be, we need these little M3x5 flathead screws. and a screwdriver. First thing you need to do is to check where you want to place your slider setup. For me, it's going to be this angle right there, then one straight side there, another straight side right here, because I want to get to the center of the desk right there. Then another straight rail right there, an ending, and then of course an ending right here. This is going to be the position more or less. So we get the round angle rail, and we're going to place the two clamps right here. They're going to slide in. As you can see, there is a profile right there that matches this profile right here. I'm going to slide it in. As you can see, it slides perfectly. We're going to match the holes for the screws. They're matching already. And we're going to place the screws. M3x5 flathead screws. The screws are just a precaution to avoid the clamps to come off. But I assure you the materials is so strong they won't come off, especially because the profile it's made on purpose. The first 4 screws are in, and now we have to do this for all the other ones. But with the magic of editing, I'm just going to show you where I'm finished. There we go, they're all done. It took a while, but finally they're done. Now it's time to place the screws right here with the soft cap, and let's do that. Also, this part took quite a while, but we're done. Remember also to print a couple of extra screws, a couple of extra caps, just in case one breaks or whatever, just in case you print a couple of more extras. So now it's time to place the setup all the way around the desk, round angle part, and it goes right there. Let's clamp it in by holding it in place. Just remember not too tight, because it could break or it can bend, just enough to hold it in place. And for this side, we're just gonna put like an ending. Now we're gonna put other 2 straight rails on this side. I'm gonna put the last straight. Before placing the last one and close the rails, we have to mount the finger screw, the finger nut, the quick release plate, and at least the base of the 2 arms. We're gonna do that right now by sliding in this like this and give it a test. If it slides, and it does, we need the nut. We're gonna see if it actually works and it holds in place. I suggest to hold it and lock it where the junctions are. So let's put on the actual arms. There are these little dents right there that locks in every side of it. One side is smooth with the dent still, but the other side has the threaded hole. So we have to make sure to put that in the right place. Now let's choose which screws we're gonna use, and I think we're gonna go with the black ones because they're gonna be pretty cool with that. So where's the threaded part? It's on the other side, so I'm gonna just screw this right there. Now we have the threaded part right there and the smooth part right here, and the dents are on the inside. So we have to choose which side is gonna be. This is the smooth one because we have the threaded part right there. Let's try it this way. And we're gonna screw it on this side. We have the thread hole on the other side. Now we can open it, place it, and it will click in every dent. But for this video, I'm just gonna use the quick release plate right there. We need to see where the actual thread is. It's on this side and the dents are on this side. So we need to screw it. It will lock in place like that. Now we get the smooth screw for the quick release plate and lock it in. This one is a little tight, but that's better. So to show you how it looks with the camera and everything, I have to switch camera because I'm actually filming with it. And here is the camera, and we're gonna place it right there with the quick release that I designed. So just gonna slide it in, clip that. Now just for safety, I rather have it this one on the other side. So I'm just gonna unscrew this one, remove it first, obviously, turn it around and place it like that. So it will hold better. Now I can screw it back, not too tight, otherwise it's gonna break. Let's screw properly everything in place. And now we can, I don't know, put something on the table, unscrew this one and rotate it, and we have something cool. So I can film B-rolls on my desk easily. If I wanna change position, I'm just gonna unscrew this one and slide it wherever I want, carefully, because the camera is heavy. Let's slide it and lock it in place, and I have another angle. And if I want to go that way, unscrew this one, slide it carefully. If you have a spare desk that you'd want to ruin or something, there are other holes that you can actually screw the whole thing in place on the desk. You see, just in case you want to have it completely fully locked. And we are on the other side. So I can have another angle, move it like that, put it in place, lock it in, and you can press record and you have a nice B-roll. And here we are completely on the other side. At the end of it, lock it in place, fix your angle, maybe go higher this time, almost on top of it. This is gonna be tough. It's gonna be a little overkill and maybe dangerous, but we'll try it. Just in case you want to film an overview from the top, this is the perfect setup. I mean, it's really sturdy, it doesn't break, it doesn't wobble. Even if I slam the table, it's not gonna wobble. This is really great. And just for the test, I'm gonna show you a clip that I'm filming with it right now. Yeah, so let's say that I'm filming like this, the actual filaments. This is the filament PETG carbon. This is the Spectrum filament mascot. And this is a great angle when you're building stuff or you're making things that you want to show in details how you make it. This is another extreme angle, and as you can see, it works perfectly. And again, you can move this around all the way you want, and you have 360 degrees freedom in every angle. You can film whatever you want with it. Like I said, be careful when you slide it, because there is a bit of friction, of course, but yeah, just be careful. What I do here is hold it up a little bit, so it won't slide to the bottom, but here we go. And we lock it in there. Done. And finally, here's the final product. I gotta say, it was really fun to make, a lot of troubleshooting, a lot of creative parts, especially designing the new quick release, and it was really fun to make. And this material, I have to say, again, it went smoothly. It's really strong and flexible, and I think it's gonna last for a very long time. This was not just a project to show off a filament, but this was a project for a practical print, and you will see that I'm going to use this slider arm rig in all the other videos. So stay tuned for that. Remember to check the link in the description down below for 20% off for 30 days for this amazing V-Filament PETG carbon. And of course, check the other filaments as well. And that's all for this video. If you stuck around until now, thank you so much for watching. If you're not subscribed yet, please do to consider so, leave a like and comment down below. My name is Alessio and this is Spectrum Filaments. I'll see you in the next video.